Today I am going to show you how we can clean the data. So here I have some training data which has some columns, two columns which contain x and y. X is the input and y is our output. So shape of our training data is like 700 into 2, means I have 700 rows and 2 columns. Now for the cleaning data, first of all we need to check that is there any null value which are present in my data or not. So checking that null value, I am just using EGNA method with the sum. So it is showing me that I have like 0 null values in my x column and 1 null values present in my y column. Okay, which is great, like means we found out that. Now we see visually is there any outlier is present in my data or not. So for checking the outlier, so there are many ways to find the outlier, but I am checking with the help of like graphical method. So let me plot the scatter plot. Scatter. So I will do that like train of x comma train of y. So this will like plt dot show method. So it is showing that like okay, I have this line which is has like there is no outlier which are present here or here. All columns which are present in my state line, all the data points or the row or the data points present on my line, or there is nothing which can weird behavior we can observe that. We can observe one weird behavior here, this point, but this point is not far away from my data, it is close to my data, so we can't say it's outlier, right? So because it's near to data, right? So we see that okay, there is no outlier present, but let's me also we need to torture data as very much as possible. In that way we need to get the insight inside the data. So how we can do that, let me show you. I will do that like x train of x dot maximum to check that what is the maximum value in my data for the x. You can see here my maximum is like 3530, right? But my data in the graphical way represent that I have only 100, the maximum value is 100 or 110, not much that, but my this method is telling us very different story. Let me check for y as well, what is the y value of maximum y value. So if you go to the max and if I hit the enter, then you can see that my y value is like 108, which is like near to our actually graphical representation, but my x value is very far away from my maximum value of x is very far away from my actual data. So this is like the condition where actually this value is not present in our this graphical representation or this graph as well, because there is no point which is saying like okay, this value is present, something like graph is ended here, right? So this is the condition where we need to find that okay, why this value is far more away from my x and what is the value in terms of the 3530 in terms of y, what is the value of y if the x is something like that. So finding that, what we can do now, we just need to use train dot lock method, which is helpful for us to find the values which are present above my 120. It's a limit which I set up. So train of x is greater than 120, then give me something. Okay, we got that one rows which contain 3530 values which has one nan value. Nan means which we found that here, okay, one nan value. So that's nan value is present here. That's why this point is not visible in our graph, because the x value is present which is outlier, which is far away from our actual range, but the y value for this data point is not present. Nan, it's a nan. So that's why x is present but y is not present, so that's why this plot is not present in our graph. So you need to find out in this way. In every time in a machine learning problem, in many ways situation come very different ways. So you have to make sure that you need to like find this value or torture this data as much as you can and get the insight of the data and find out what is the affecting in my actual result, what is the present in my actual result. So you can see that this value is present and we need to clean up this value, because if we use like a outlier treatment method, which is like mean, median, mode, or something like that, but still it's not workable, because this is already the outlier in terms of x, and if we put the nan as a median of this y column, then this will be no sense, because this is the already the outlier. So instead of like replacing the nan value with the median, mode, or mean any other way, we can directly just remove this row. In that way we will get like, okay, this our data will be normally distributed once we remove that row, because this is the outlier and affecting our data. So let me remove that. So we can do train dot drop na, train dot drop na. So I want to remove the value on the axis is equal to 0, because I want to remove the value in the row wise, not a column. I don't want to remove any column, right? I want to remove that specific row, ENA rows. The row which contain ENA value, I want to remove only that row, and only this row contain the ENA value. So this row will be deleted after running this command. So if I run this command, you can see here, okay, this is giving me all the data points. So for the like this is okay, if I hit enter, you can see that if I do here like train dot EGNA and dot sum, and you can see that my value is still present, right? Why this is not removed in the drop NA method? Because it's not assign these things to the train, it is just removing my NA values and printing the output. So doing or assigning this all the data set to the train, we need to use in place attribute, in place equal to true. So if you do that, then it's like in placing or changing the value in actual data set. So it's not giving us the values after the changing the data set, it's just changing the actual value, not a thing. If I run this like train each sum or checking the null values, you can see that now I have like 0 rows which contain NA values and 0 columns which contain NA values, means nothing, no nan present in my data set. Now we can hit this graph and you can show that, okay, this graph is now actually the actual representation of our data. So now let me run this one, like if the value is greater than 120, not a present. Let me do here like 101, not a present, right? If I do 100, then not a present. If I do 99, then there is some values which are present, which is like actual behavior of data. Because if you see here, the 99 here is the point, right? And in my point there are some data points present. So that's why it's okay. It's okay to be the 90 is there. But you can see that, right? How we can find the outlier which are actually not represent or not pointing in our graph, but that outlier is present in a hidden way in our data. So this is the analysis we need to do that. This is the one process I am going to explain in this video, how we can find the hidden outlier in our data. So thank you so much for watching this video.